So the last video was going a little too long. I did not believe I was going to be able to fit this in. I have a 15-minute cap, unfortunately. So example 4.5. It has to do with basically cell phone usage, or people actually have cell phones. So in the year 1990, 5,280 people had cell phones, and then basically this information has been tracked over the years, and it appears to be exponential. Now, yeah, it's somewhat linear, but it's definitely curving. So it looks like at some point you can say with some certainty, hey, this information here is exponential. For some reason they left out 1991, 1992, but that's not going to be super important. Now, on the guided notes I gave you guys, I asked you guys to copy this over again, and then we talked about the ratios. In order to find these ratios, you have to divide by the previous year's information. Now, given that there's nothing before 1993 that we actually have, we don't have 1992, and we don't have 1989, we can't calculate these ratios. But we can calculate the rest of these. If I want to calculate 1994, I take this number and divide it by this one. So, let me just show you what that looks like real quick. So, 24,124, that's going to be divided by, that's the information from 1994. The information from 1993 is 16,009. So if I enter that correctly, I get this number here. I'm only going to use these first two decimal points here. So I'm going to put right here, 1.52. Now, I already have the rest of them on here. Actually, sorry, 1.51. So these are the ratios. Now, the only reason I'm asking you, or I asked you guys to calculate these ratios was to see that there actually was some pattern. At some point, things do tend to level off a little bit, but, that's how it goes. Now, for this last part, you need to find log of y. Now, y, in this case, happens to be the subscribers. So I already have this information entered into the calculator, just to save some time on this video. So this is list 1, that's the years. List 2 is the subscribers. So for list 3, I want to have the list, I want to have a list that basically incorporates the log of the subscribers. So I hit log, and then I hit list 2, and then enter it for me. Now, this log of y, this is my new observed value. So whenever, for example, if I need to do if I need to do a least squares regression line, it's going to relate to this information here. This is going to be the observed. The least squares regression line would give me the predicted value. Now, I do want to calculate a least squares regression line, which is going to be somewhere down the line. Now, these were the rules that we went over as a class. These apply to log. When you apply log to a least squares regression line, you still want to, well, not necessarily a least squares regression line, to like an exponential function or a power law, you want it to look as close to a least squares regression line as possible, and here are the rules to do that. Now on this next slide, I actually have the work for how to turn this right here into something that looks like the least squares regression line, and it's actually a little cleaner down here, so let me go ahead and switch down here. This right here is actually an exponential, growth model. So y is equal to ab to the power of x. Now we don't know what a and b are, but those are basically going to be the log of a and log of b at some point. Those are going to be our intercept and our slope. So this looks similar to, y hat equals a plus bx. It's just slightly different. It's very much like the chapter before. The only difference now is we're applying some function to our pre-existing work. Now, at some point, you are going to be asked to find the least squares regression line, so let's go ahead and do that on the calculator real quick. So remember, you're going to go to Stat, Calc, A is the least squares regression line. I want to calculate that for the years, and I also want to calculate it for basically log of y. So that's list 1 and list 3 for me. So this is the years, and this is basically log applied to y. Now I do want to store this, so I'm going to go to vars, y vars function, and then set that for the first one, and then calculate. Now I would write these two down as my a and my b for my least squares regression line, which I will have on the next slide. And then it also says to graph the least squares regression line. So let's go ahead and do that on here. So I want to set my plot, and I want it to be my years, which is list 1, and I want it to be list 3, which is basically log applied to my subscribers. So zoom 9, and this is what it looks like. Now, special note, if a variable grows exponentially, its logarithm will grow linearly. So again, the original data for this, we can tell that it was going to grow exponentially, so applying log is supposed to make it more linear. That scatter plot looks pretty linear to me. In fact, most of them land like right on the least squares regression line or really, really close to it, which is a good thing. Now, here's the thing. The only way to determine if that least squares regression line is appropriate for actually predicting stuff is to calculate the residual plot. So, important things to know, a residual plot should have no pattern. If there is a pattern, that means, it's not gonna yield the best results, which it says down here. So let's do that. So I do want to do my residual plot. First we have to calculate y hat, which is the predicted value. So what I'm going to do is, I have this equation loaded in here. So I'm going to use this equation to find my predicted values. I'm going to go to list 4. I'm going to go to bars, y bars, function, the one that has my actual function, my least squares regression line, and I want to plug in my first list. My first list is the year, so it's very important you plug in your explanatory variable here, your x value. So I plug that in and I get these numbers. Now, these should look very similar. This list right here has log applied to it. This right here is my observed. This is my predicted one. They should be relatively close, and then for list 5, I'm going to calculate the residuals. I want to do list 3 minus list 4, and these numbers should be really small. So as you can see, they're all below 0, which is ideal. Now let's actually let's graph the residual plot. So to graph the residual plot, you graph your x, which in our case is the years, versus the residuals, which is list 5 for us. So I'm going to go back up here, and I'm going to change this to list 5. Now I'm going to go back to here for a second, if it'll let me. I have these from the previous video, so I'm going to take these off real quick. I don't want them interfering with my work, and actually I'm just going to go ahead and start just clearing them. Don't need these anymore. Now I'm going to go zoom, stat plot. Now these form a pattern. That is not a good sign. Whenever it does form some kind of pattern, like right here it looks like it's curving, if I had 1991 and 2, they'd probably be here and here. This is not a good sign. So what this means is either stop right here, or if you know how, which I'm a teacher right now, reduce your data. Now, ultimately, my goal for this problem is to be able to predict how many people have cell phones in the year 2000. So I'm going to take off the first 4 from my list, because those are further away from the year 2000. So what I'm going to do first is delete them from list 5 and delete them from my first list. So I have 4 here and 4 in that list, and I'm going to do the residual again. And look, I still have a pattern, so I still have an issue. So the reason I have an issue here is I did not recalculate my residual. So what we have to do is do that. Recalculate the residual. So I'm going to go back to here, and I'm going to delete 4 from every list. But at this point, I actually need to redo the other ones anyway, so I'm going to stop right here. I'm going to apply log again. I'm going to apply it to my new list 2. So list 2 only has the latest 4 years in the amount of subscribers. And then for this one, I have to calculate a new least squares regression line because the old one's not going to work. The one that I have right here currently, this applies to the data that actually has all 8 points. It's not going to work. So I need to redo that. So I'm going to go here, and then this does not change, and this does not change. I still want to have the same function. I'm going to replace that one with my new one. So now I have, this is my new A, this is my new B. This should give me hopefully better results. So I'm going to go here, go to bars, y bars, all that business, get my function, And I'm going to plug in list 1 again, because list 1 is my years, is my explanatory variable. And then now I'm going to recalculate my residuals, because I need my new ones. So, again, to calculate residual, list 3 is my observed variable, list 4 is my predicted, and now I have these numbers here. So hopefully now I should see no pattern. So I need to go back to here, just to confirm. So I do have that. I'm going to go here, and now there's no pattern. Now some of you might be tempted to say, hey, it looks like there's a pattern here. Well, this is only 4 points. If we had a lot more points, it'd be more obvious there was no pattern. So unfortunately, with smaller data sets, it's kind of harder to see. Now, I do want to make a prediction at some point. So, let's go down here. So I had you guys write this down just for practice. This right here is just explaining to a student how I went from this to this. If you wish to look through this to see how this happened, you're more than welcome to look at it yourself. Pause the video. So this is basically going back to Y for the first list, but I'm not going to use this one. What I am going to do is I'm going to use this right here. Now ultimately I want to plug into this right here, but if you plug this in as it is into your calculator, it's going to give you overflow. That's an error. So there's actually a pretty simple workaround for that. The simple workaround for that is to actually plug this into your calculator, which I'm going to do right now. I'm going to plug it in here. And actually I don't have to plug it in. I already have it. It's right here. So this is going to give me my most accurate answer. Now, here's the trick. In order to make this work, I still need to have 10 in here somehow. So what I'm going to do is I'm going to plug in 10. So I'm going to go second log. And then right here, I'm going to plug in the previous function. So I'm going to go vars, y vars, and the first function. Because that first function is my least squares regression line. And then this 2 is just here. So I'm going to go ahead and delete that. Now what I can do is I can go to my home screen. I can use my second function to calculate this. Now I want to predict for the year 2000, so I'm going to plug in 2000 here. And then I get 107,864. This actually makes a lot of sense. So if I actually go back up to the original list, in 1999 there was 86,000 approximately people that had cell phones, and this number here actually makes a lot of sense. This, logically to me, would be the next year. So this would give us a more accurate prediction than the other one. And I think that's pretty much it. The only thing I want to say is, this chapter essentially is the same thing as the last one. The only difference really is, there's one more step. That one step is a transformation. So you have transformed, observed variable, transformed predicted variable, that gives you a residual. Everything else pretty much works the same thing. It's the same way. You want it to be linear, make it linear.